Given the input list, input is 435, we have initially an empty resulting list, which is result is empty. We then iterate over the input list. For the first element 4, we need to find a proper position in the resulting list to place it. Since the resulting list is still empty, we need to simply append it to the resulting list. For example, result is 4. Now, for the second element 3 in the input list, similarly, we just need to insert it properly into the resulting list. As we can see, we need to insert it right before the element 4. As a result, the resulting list becomes 3, 4. Finally, for the last element 5 in the input list, as it turns out, the proper position to place it is the tail of the resulting list. With the last iteration, we obtain a sorted list. As a result is 3, 4, 5. Let's try another example. Names is 4, 2, 1, 3, and we split it to 2 parts, sorted and unsorted. Let's start iterate. First, we append the first element in the names to the sorted part. Then we insert the second element 2, but 2 is less than 4, so we insert it left before the number 4, and the number 4 should shift backward 1 position. Then we insert the third element 1, but 1 is less than 2, less than 4, so it should be inserted in the leftmost of the sorted part, and then we should shift backward 1 position by 2 and 4. Let's insert the last element 3. 3 is less than 4 but greater than 2, so it should be inserted between 2 and 4, and we just need to shift 4 backward 1 position. So finally we get 1, 2, 3, 4 for the sorted part, and the unsorted part is empty, so we are done. So let's try another example, which is LinkedList 4, 2, 1, 3, and we set a DOM node, which is used as a references, and we have 3 pointer, preview pointer, which is indicate where we insert the new element, which is after the previous pointer, and we also have the current pointer and the next pointer, which is indicate the rest of unsorted part. So let's start iterate. First, the current pointer pointing at 4, we just unlink 4 and move 4 just right behind the dominant node, and then we just move forward the current pointer to 2 and the next pointer to 1. So this time the current pointer is pointing at 2, so we just unlink 2. 2 is less than 4, so we just move 2 left before the 4. So then we just move forward the current pointer and the next pointer. So this time the current pointer is pointing at 1, we just unlink 1, but 1 is less than 2 and 4, so we just move 1 left before the 2 and 4, and then we just move forward the current pointer and the next pointer. So this time the current pointer is pointing at 3, but 3 is greater than 1, so we just move forward the previous pointer, and 3 is greater than 2, so we then also move forward the previous pointer, and 3 is less than 4, so we just insert the 3 between the 2 and 4, and then we can move back our previous pointer, and then we have to move forward the current pointer and the next pointer, but it pointing at none, so we are done. We get our result, which is the node 1, 2, 3, 4. So to translate the above intuition into the implementation, we apply 2 tricks. The first trick is that we can create a dummy node, which is pseudo head, which serves as the pointer pointing to the resulting list. So more precisely, the node facilitates us to always get the hold on the resulting list, especially when we need to insert a new element to the head of the resulting list. One will see later in more details how it can greatly simplify the logic. So in a singular linked list, each node has always one pointer that points to the next node. If we would like to insert a new node B before the certain node A, we need to know the node C. So that is current before the node A, which is the node C pointing at node A. With the reference in the node C, we will now insert the new node, which is C pointing at B pointing at A. So given the above insight, in order to insert a new element into a singly linked list, we applied another trick. The idea is that we use a pair of pointers, namely previous pointer pointing at next pointer, which serves as placeholders to guard the position where in between we would like to insert a new element. So which is previous pointing at new node pointing at next. Okay, so let's see the same example, which is input 435 and point to the end, and we just set a pseudo head pointing to the end, which is our dummy node, and then we set 3 pointer current, preview, and next. So because the current pointer at 4, we just move 4 into between the preview and the next. So in the second time, the preview pointer pointing at the pseudo head, and the next pointer pointing at 4, and the current pointer pointing at 3. So we just move 3 into between the pseudo head and 4. But the third iteration is more tricky because the current pointer is pointing at 5, but 5 is greater than 3, which can be inserted before 3. So we have to move forward. 5 is greater than 4, so we have to insert right behind the 4. So the 2 pointer, previous pointer and next pointer should move forward 2 times before we insert, so that we can insert the current pointer 5 into the previous pointer and next pointer. So finally, the current pointer is pointing at the end, and the previous pointer is pointing at the end, and the next pointer is run out of the boundary. So let's analyze the space complexity, which is of1 because we use some pointers within the algorithm. However, the memory consumption is constant regardless the input node, and we didn't create any new node to hold the values of the input list, but we just simply reorder the existing nodes. So let's analyze the time complexity. First of all, we have to run an iteration over the input list. So at each iteration, we have to insert an element into the resulting list. So in the worst case, where the position to insert is on the tail of the list, so we have to work through the entire resulting list. So let's take example 1, 2, 3, 4, 5, this list. How many times we have to work through, which is 1 plus 2 plus 3 plus 4 plus 5. In summation, which is 5 multiplied 5 plus 1 divided by 2, which is 15 times. So as a result, the total steps that we need to work through in the worst case would be sigma summation of I start from 1 to n. So the result is n multiplied by n plus 1 divided by 2. So to sum up, the overall time complexity of this algorithm is O of n squared. Okay, so let's start. First, we define a list node which have 2 variables, value and next. The default value is 0 and the default next is none. And then we take an example as our input items, which is -1, 5, 3, 4, and 0. We set a -1 as our step, which means move backward. 0 pointing by 4, pointing by 3, pointing by 5, pointing by -1. So these are our list node instances. Now we can set our dummy node, which have the default value 0 pointing at none, and we know the head is the beginning of the node, which is -1. So we can set our first pointer current, which is assigned by head. So let's set a while loop. While current exists, we will execute the following code. First, let's set a previous pointer, which is pointing at the dummy node 0, and then we should judge the previous.next is none. None means not exist, so we can set our next pointer is assigned by current.next. So let's start our insertion. First, we unlink the -1 with 5, and we connect the current node.next with the previous node.next, and then we disconnect the 0 with none, and we connect the previous node.next with the current node. So this is our insertion. So after we finish the insertion, we just update our current pointer, which is assigned by the next pointer, and above is our while loop. So let's start another while loop. While current is exist, we update the previous pointer, move back to the DOM node 0, and then we compare the previous.next with the current point. The current value is 5, which is greater than -1, which is previous.next value. So in this case, we should update the previous pointer assigned by previous.next, and then we judge the previous.next, which is known. So in this case, it didn't exist, so we just update our next pointer assigned by current.next. So let's start our insertion. First, we just unlink 5 with 3, but link 5 with known, which is right behind the -1, and then we unlink -1 with known, but link the -1 with 5. So we are done. This is our insertion. We then just update the current pointer assigned by next pointer, and this is our second while loop. So let's start our third while loop. While current is exist, the previous pointer is moved back to pointing at the DOM node 0, and the previous.next.value is less than current.value because -1 is less than 3. And this time we should move forward our previous pointer assigned by previous.next, and then we compare the previous.next.value, which is greater than current.value. That means 5 is greater than 3. So in this case, we should update our next pointer assigned by current.next. So let's start our insertion. First, we just unlink 3 with 4, and then we link 3 with the next node of -1, which is 5, and then we just unlink -1 with 5, but link the -1 with 3. So we get -1 linked 3 linked 5, so I'll finish our insertion. Then we just update our current pointer assigned by next pointer. So this is our third while loop. So let's start our fourth while loop. While current is exist, we move back our previous pointer to pointing at DOM node, and then we compare the previous.next.value, which is -1, is less than current.value, which is 4. Then we should keep move on our previous pointer assigned by previous.next. Then we compare the previous.next.value compare with the 4, which is also less than 4, and we should keep move on our previous pointer assigned by previous.next, and we compare previous.next.value, which is 5, is greater than the current.value 4. So we finished. We just update our next pointer assigned by current.next. So let's start insertion. First, we just unlink 4 with 0, but link 4 with 5, which is the right behind the node 3. And then we just unlink 3 with 5, but link 3 with 4. And then we get 0 pointing -1, link 3, link 4, link 5. And then we just update our current pointer assigned by the next pointer. So this is our fourth while loop. Let's look at our last while loop. While current is exist, we move back the previous pointer to pointing at DOM node 0, and then we compare the previous.next.value with the current value, which is -1 less than 0. Then we should move forward our previous pointer assigned by previous.next, compare with current.value. 3 is greater than 0, so we just stop and update our next node, which is assigned by the current.next, but current.next is known, which means it didn't exist, so the next pointer is also assigned by known. So let's start our insertion. First, we just unlink 0 with known, but link 0 with 3, which is the next node of -1, and then we just unlink -1 with 3, but link -1 with 0. So we finally get 0 linked -1, link 0, link 3, link 4, link 5. So we then just update the current pointer assigned by the next pointer. So both of them is pointing at known. So this is our final while loop. So let's try another while loop. While current is exist, no, it is false. The current is not exist because it is pointing at known. So we are finished. We just recognize our DOM node, which is 0, and then we just return the DOM node's next nodes. So this is our final result. So let's try to implement the algorithm in Python. First, we just define a class list node. which is single list load. Then we define the double underscore initialize double underscore, which have self and value. The default value is 0, and the next value is default is none. Then self dot value is value, self dot next is next. Then we can build a class solution. We define the insertion sort list. It have self and head, which is list node, and we output a list node. Then first we set a pseudo head DOM node, which is list node, and then we set our current pointer, which is head. Then we can start our iteration while current is exist. So at each iteration, we can insert an element into the resulting list. First, we set our preview pointer to always pointing back to the DOM node, and then we need to find a position where should we insert the current node. So while preview.next is exist, and preview.next.value should, if it is less than the current value, that means we should move the preview pointer to the next preview.next. So until it is equal or greater than current value, so then we can update our next pointer is assigned by current.next. Then we can insert our current node to the new list. We just link the current.next with the preview.next. Then we link the preview.next with the current. So we link them together. So after we finish our insertion, we just move on our next iteration. That means we update our current pointer. Current is assigned by next. So after we finish our while loop, we just return the DOM.next. So in the right of the DOM node is our result, right? So we can output our example. Next is start from none, and for item in the list 4, 2, 1, 3, and we move backward, which means -1, or move backward by one, and then the next is list node item and next. Then the result is solution dot insertion sort list next. While result is exist, we just print the result dot value one by one, and after we print, we just move to the next one until result is known, until then we finished. Yeah, that is how it works. We just sort the linked list 4, 2, 1, 3.